We're going to make the jump to chapter 5, still dealing with triangles. They're just not going to be right triangles anymore. So the word oblique in geometry covers every kind of triangle that isn't a right triangle. Under the category of oblique, you've got lots of different kinds. We have scalene, we have acute, we have obtuse, equilateral, isosceles. But the nice thing is there's not a separate rule for all of those different categories. They all just fall under the rule or the category of oblique. We've got one rule that covers all of them, which is great. And that rule is called the law of sines. So let's take a look at what that is. I'm going to give you a sample of an oblique triangle. So there's an oblique triangle, no right angles. None of the corners are 90 degrees. They're all different. I think I showed you this before. We use capital letters to indicate the vertices of triangles. So we would use capital A, B, and C. And sometimes on the letter C, you'll see people write just an extra little line right there to indicate that it's the capital, because sometimes it's hard to tell the difference between what's a capital C and what's a small c. We use lowercase letters to go on the legs of all the triangle, and they're always directly across from the angle itself. So if angle A would have leg A or side A directly across from it, and angle B would have side B directly across from it, and then angle C over on the opposite side. Okay, so the idea of the across is going to be important for the law of sines. When you notice you're using a triangle that doesn't have any 90-degree angles, it's like when you see a right triangle, you're like, ooh, automatically know that it's going to be Pythagorean theorem or SOHCAHTOA. For an oblique triangle, you automatically know that the following is true. The sine of A, when it's divided by its opposite side of A, if you compare that to the sine of B divided by its opposite side of B, and lastly, if you compare that to the sine of C, capital, divided by lowercase c, you will find that all three of those fractions are all equal to each other. They all have the same value, and that is the law of sines. You can take any relationship between sine of A and regular A compared to sine of B over side B and then sine of C over leg C, and they will always have an equal value. That is the law of sines. And so we use that law or that property to help us solve for the missing parts of a triangle. So a triangle has 6 parts altogether, 3 corners, 3 legs. Every question that you'll have tonight, you'll be given 3 out of the 6. You'll be given 50% of the information, and your job is always to find the missing parts. You'll be given a different combination of them every single time, but you'll always have 50%. So your example might be something like this. Complete the missing parts of the triangle. And it's always helpful, I think, to organize yourself like this. Set up your capital ABC in a column, set up your leg ABC in a column. And like I said, of those 6 parts, you will always be given exactly 3. All right, what you're going to be given this time is 49 degrees for A, 28.7 degrees for B, and 27.4 for little b. So the first thing you want to do, the easiest thing to do, is to find angle C, because no matter what kind of triangle it is, what do you know about all the angles of a triangle? They do. All, regardless of whether it's oblique, scalene, obtuse, right, they still have to add up to 180. And so the first and most easy thing to do would be to start with 180 degrees, take away 49 for angle A, take away 28.7 for angle B, and you'll be left with 102.3. So that would be the first thing to do, is to find that easiest part. Now you verified that this is not a right triangle because none of the three corners are right. In fact, this is an obtuse triangle because it has something that's larger than 90 degrees. And so as soon as you know it's not a right triangle, then we're going to use the law of sines. The law of sines tells us that I can line up sine of A over the leg of A. And so I'm going to take sine of 49 degrees over the leg of A. I also can take the sine of B, which is 28.7 degrees, over the leg of B, which is 27.4. And I know, according to the law, that these two things have to be equal. So I'll just stop here. I'm not going to do the C part quite yet. I'll do these two first. All right, I know that they are equal. What does that set up to look like to you? Exactly. These are proportions, and you cross multiply them. And we're trying to figure out what leg A would be worth. And so we're going to cross multiply. So that will give me leg A cross multiplied to the sine of 28.7 degrees. And it will give me 27.4 cross multiplied to the sine of 49 degrees. I find it best practice to always put the leg in the front and then the sine part in the back. All right, now we want to get A by itself, and the quickest math to do that is what? Okay, we are going to divide. So we're going to take this division here, and we'll divide by the sine of 28.7 degrees. The word sine does not cancel out. You can't just like reduce the word, because sine is a word, it's not a number. We only can reduce numbers. So you're not going to reduce, but you're just going to type that straight into your calculator. So it's pretty straightforward. 27.4 times the sine of 49 degrees divided by the sine of 28.7 degrees. And as long as you are in degree mode, you should get 43.06. All right, so that completes the leg for A. So I can go back to my list, and I now know that is 43.06. To find leg C, I can't use the Pythagorean theorem. A squared plus B squared equals C squared does not work because this is not a right triangle. And so I need to continue my law. The rest of the law said, well, if you continue from the sine of B over leg B to the sine of C over leg C, that would continue as well. So we continue, just picking up where we left off. We'll do the sine of B now. Sine of B is the sine of 28.7 degrees over the leg of B, which was 27.4. And I'll set that equal to the C parts. So that would be sine of 102.3 degrees over the leg of C. And you'll do the exact same thing. You'll cross multiply those proportions. Again, I always find it best practice to put the legs in front. So the C leg, the leg of C, would be in front of sine 28.7. And the leg 27.4 would be in front of the sine of 102.3 degrees. And we'll use division again. Divide by sine 28.7 degrees. And then you'll have C by itself, which turns out to be 55.74. one of the smallest little mistakes that I see people make is that they just don't use the word sign. They'll do 27.4 times 102.3 divided by 28.7. They'll leave the sign out of it altogether. Okay, that would be incorrect. So we got 5574. And now we have completed the 6 parts of the triangle, the 3 that we needed to find. Any questions on that one? It's pretty straightforward. Okay, now let me give you a different problem that has 3 different pieces. The directions are the same. Complete the parts of the triangle. Okay, this time, capital A, capital B, capital C, and little a, little b, little c. Okay, this time I'm going to give you little a is 35. I'm going to give you little c is 50. And I'm going to give you capital C to be 85 degrees, 20 minutes. So you'll always get 3 and have 3 to find. Now I can't use the law of 180 because I only know one angle right now. I can't use the law of 180 unless I knew at least 2 angles. So I'm going to have to start with a pair. And it's always best to start with the pair that you know both parts of. So which pair do I have both parts of? C. Start with that. Okay, so I'm going to start with the sine of C, which is 85 degrees, 20 minutes, over the leg of C, which is 50. And then I'm going to set that equal to the other proportion, but where at least I know one of them. I know part of it, which is going to be the A part. Now, it's going to be sine of A, which I do not yet know, over the leg of A, which is 35. So you'll set up the proportions this time. It's the C proportion of the C's, compared to the proportion of the A's. I knew everything for C, but I only knew half of the A pair. That's okay, we can still cross multiply. So we'll cross multiply. Remember, write the leg in front. So 50 would go in front of sine A, and 35 would go in front of sine 85, 20. What do I do first to work towards getting capital A by itself? Divide by 50 first. So that would give me sine of A equals 35 sine of 85 degrees, 20 minutes, divided by 50. That still doesn't give me A alone yet. Okay, one more step, which would be what? Inverse, okay? And so A by itself, now when you use inverse, make sure you put parentheses around the whole big thing. Parentheses around 35 sine 85 degrees, 20 minutes, all over 50, and then close your parentheses. Okay, the calculator needs you to put those parentheses in. If you fail, it'll even, I think, prompt you with the parentheses. Okay, this works out in DMS mode to be 44 degrees, 14 minutes, and 28 seconds. So we got pretty specific when I type that in and change it into DMS mode. Okay, you'll make sure that you do DMS. If the problem starts in DMS, then your answer should be in DMS. If the problem started in decimal, your answers can be in decimal. This problem started in DMS. Okay, so I'm going to come back up here. So I now know A to be 44, 14, 28. Now I can use the law of 180 degrees to figure out what the value of angle B should be. So I'll take 180. I'll subtract the 44 1428. I'll also subtract the 8520, and that will give me the value of what B is, and that works out to be 50, 25, 32. All right, my last step is to figure out the remaining leg B, which will get me, I have to set up another proportion. So your math is always going to be two proportions and a law of 180. The order that you do that in is going to depend on what you're given, but we want to set up a proportion. You will get the most accurate answer if you always set up your proportion starting with the pair that you were given. We were given the C pair, so we're always going to start with that, and then we're going to compare it to the B pair this time to find the rest. So our C pair was 50 over, C pair, sine of 8520 over 50. And now I compare that to the B pair, which I'm still looking to find, which would be the sine of 50, 25, 32, all over leg B. And once more, we cross multiply. Leg B is now in front of the sine 8520, and 50 is now in front of the sine 50 degrees, 25 minutes, 32 seconds, and we divide both sides. So 50 sine 50, 25 degrees, 32 minutes would be eventually divided, bless you, by the sine of 85 degrees, 20 minutes. Again, let your calculator do that work for you. Don't reduce the word. Type that in as is, and you'll get 38.668 to be the length of the final leg. Perfect.